Hello and welcome. In this video we're going to be having a look at Gaussian elimination, which is a process which can be used to solve equations. This video is sort of theoretical. We never really do this in game development, but it is just good to be comfortable working with matrices, because later on when we find inverses of matrices, which we might sometimes want to do in game development, this is a process which the computer sort of performs under the hood. Anyway, so I'll just do this by example. Let's say we have a system of equations. Here's our system. We have 3 equations and 3 unknowns. We can pose this as a matrix problem. So we have some coefficient matrix. We transform an unknown vector through it, and the result is this right-hand side. So this is the, first row, first column. We get that by transforming the first row through the first and only column. So that's 1 times x, negative 2 times y, plus 1 times z. And we can follow the same process and fill in the rest of the matrix. Okay, so how do we solve this system? Well, later on in the series we'll look at inverses, and that solves it pretty quickly. But if we want to solve it by hand, we can write this together as what's called an augmented matrix. And this is essentially taking the coefficient matrix and the right-hand side vector, sticking them together. Okay, now, what I want to do is I want to take this first row, first column, and I want to perform operations which will zero out all of the elements below in that column. So what I'm going to do is I'm going to, this essentially, it's like an equation. It is an equation, as a matter of fact. So I can take the second row and I can say the second row will be the second row minus 2 times the first row. That, in other words, we'll have 2 minus 2, that will cancel that element out. And then we can look at the third row, and we can say the third row will be the third row minus 4 times the first row, and that will zero out this element. So we can perform these operations. Now we have to perform the operations on the right-hand side as well, but because this is 0, subtracting 0 will do absolutely nothing. Now here we have 2 minus 2, which is 0. And then we have 2 minus negative 2. Oh, sorry. Why am I doing that? 1 minus negative 2 is positive 3. And then negative 3 minus 2 is negative 5. Then down here we have 4 minus 4, negative, what am I doing? Negative 7 minus negative 8, so that's negative 7 plus 8 is 1. And 1 minus 4 is negative 3, and the right-hand side is unaffected. Okay. So this is my favorite topic, Gaussian elimination, not because it's tricky, because it's easy to make mistakes. Now, if you look at the first column, everything's zeroed out. That's great. Now we look at the second column, we want to zero out this element down below. And what we can do is we can say row 3 will be, I want to cancel things out, so I'm going to take row 3, multiply it by 3, and then subtract row 2. In other words, this element will become 3. 3 minus 3 is 0. Okay, so we'll perform that over here. Okay, so of course we have 0 here. Now this becomes 3. 3 minus 3 is 0. This becomes negative 9. Negative 9 minus negative 5 is -4. This becomes -3. -3 minus 5 is -8. Okay, so we have this in row echelon form. Row echelon form means that essentially, well, we can say it's nice. It's solvable. So it's kind of like upper triangular form, as we can see here, or lower triangular form, however you want to describe this. However, it doesn't have to be a perfect triangle. So if we had this row removed, that would still count as row echelon form. Row echelon form just means that going down the column, anything in this column below the diagonal is 0. Okay, so we've got this set up. Now we'll perform the final step, which is called back substitution. So I look at row 3 and I say, what does row 3 tell me? Row 3 tells me, if I read this off as an equation again, -4 times z equals -8. No problem. Divide both sides by -4, and this tells me z equals 2. Okay. Then I back substitute and I say, look at row 2. Row 2 tells me that 3 times y plus -5 times, and I know that this is -5 times z, I know that z is 2, so I substitute that info in, equals 5. Okay, so 3y, and this is -10, so add it to both sides. 3y is 15, y is 5. Okay, awesome. Now I look back at row 1. What does row 1 tell me? Row 1 tells me that x plus, and then we have -2 times 5, so -10, plus 1 times 2 equals 0. In other words, x minus 8 equals 0, x equals 8. So there we have our solution to the system. Okay, let's have a look at another example. As usual, we want to sort of zero everything out down below this 2. So we go to row 2 and we say, let row 2 be row 2 plus 2 times row 1. And then we'll say, okay, let row 3 be row 3 minus 3 times row 1. Just double checking, seeing I haven't made any errors. All right, so just being through here, just double checking, looks like there are no errors. Now, I have a kind of funky situation, but let's keep going. Okay, so this first column, everything's been zeroed out. This second column, yep, we don't need to zero anything out. Now the third column, I want to zero out down here. So what I can say is I can say row 3 equals, and I think of the lowest common multiple of 6 and 4, which is 12. So I'll go 2 times row 3, that'll give me 12 there, plus 3 times row 2, that'll give me -12 there. Okay. Okay, there we are. So we got sort of a funky situation. It is in row echelon form. Now, if we look at this third row, row 3 is telling me that 0 times x plus 0 times y plus 0 times z equals 6. This is not possible. That's just not how numbers work. So therefore, this has no solutions, this system. All right, and let's have a look at one last example. Okay, here's our last example. So we'll go through the usual process, zero everything out on the first column. Actually, I'm just going to change this number. We'll go with that one. Okay. Go with the half. Okay, fine. So we've got that. Now what we want to do is if we just take this row, this column, and zero everything out. So then we'll go, okay, row 3 is row 3 plus row 2. Now if we add this together, note that every element actually comes out to 0. So again, this is in row echelon form because for each row, everything to the left of its diagonal is 0. Now let's have a look at this. We look at row 3. What does row 3 tell us? Absolutely nothing. We have 0 times x plus 0 times y, 0 times z equals 0. That's what I would expect. Let's think of it actually in terms of restrictions. An equation is sort of a restriction on x, y, and z. Here we really don't have an equation, so we don't really have a restriction. Now, the tradition I like to follow is I use the third row to tell me information about the third variable. I use the second row to tell me information about the second variable, and so on. So we have no restriction, and I'm going to say no restriction on z. So let's let z be some real number, alpha, so really just a free parameter, anything at all, and then we can use that later on. So we go to row 2, and row 2 tells us that y plus negative 3z, so negative 3 alpha, equals 1, and this tells us that y equals 1 plus 3 alpha. And then we can have a look at row 1, and row 1 tells us x plus y, which is 1 plus 3 alpha, plus z, which is alpha, equals 2. Okay, so just rearrange everything and we get x equals 1 plus 4 alpha. So there we have our solutions. Z equals alpha, y equals 1 plus 3 alpha, x equals 1 plus 4 alpha. And note that we have a free parameter, so we actually have an infinite family of solutions. So this is sort of gone through the three main cases for systems of equations, linear equations. We can have a unique solution, single unique solution, no solution, or an infinite family of solutions. So that's it for this video, and I hope you enjoyed that.